want to talk a little bit about what we do at Coda. I think a lot of the discussion today has been about computation. I want to shift the focus a little bit more to an allied area of modern computers, that of networking. And Coda in particular is more focused on transportation networks rather than computer networks. But I think it's really starting to converge quite rapidly, as I'll discuss. So obviously we're here today talking about the 70th anniversary of Australia's first computer. But I think it's worth noting that of these first computers that were built, and for quite a number of years after the very first computers, they weren't networked, they were standalone devices. And really, the only inputs they had were from humans or sensors. I think in the case of the CIRAC case, it was just paper tape, and the only outputs were to screens or printers, or in the case of CIRAC, just the ability to produce a tone and some sort of audible output. But as we built more and more computers, they started to become networks. And as we now know, the more connections that they had, the more value that was created. I think that's really what we call today the network effect. And that's illustrated here with a simple example of telephones. Obviously, if you've got the first telephone, it's really of no use to you whatsoever, no value. Once you have a second telephone, you can call one other person. Then as we go, you could go to 5 telephones, and suddenly everybody's able to talk to 4 other people. We go to the 12 telephones shown here. At that stage, everybody in the network can talk to 11 other people. And that's really now known as the Metcalfe's law, and it's really that the value of a network is proportional to the square of the number of users of the network. So, it can really grow massively once you get large numbers. And that's really what's led us to, the internet revolution. So the really explosion of value that happened for the computers once they started to become networked and the internet really started to grow. And even today, that grows further with the Internet of Things. So the number of users of the network are more than just the human users, but it's also the things that are starting to generate value from the network. However, when we look to transportation networks, they really still consist of a lot of disconnected devices. Each, in a modern vehicle, they're very powerful computing platforms, but today they're really unnetworked, or really at best networked in quite a rudimentary sense with a human in the loop. So we as drivers, we will observe the stops, the brake lights of the car in front. We'll observe the indicators of cars as they're indicating that they want to turn, and we'll react to that by applying brakes or accelerator as we need it. So very simple. Likewise, we'll be also networked into the actual roads themselves, but that may be just observing what the red and green lights are doing, what the traffic lights are doing. But that's really starting to change. We're really starting to see cars becoming connected, and that's really starting to create some big values. So that's really where we come to today. We're starting to see connected vehicles. So by this we mean there is actually a radio in each vehicle, and it's communicating with all the vehicles around it. So we do vehicle-to-vehicle communications, sharing with all the vehicles around them 10 times a second information such as position, speed, heading, brake status, steering wheel angle, and things like that. And so that can really create some big safety outcomes. So imagine you're driving down the road towards a blind intersection. There's another car approaching on the side road. Now you've got the right of way, but the other car is travelling too fast, it's not going to stop in time. Well, you can't see this situation, but with the systems in both vehicles, the computers in both vehicles can be communicating 10 times a second, be aware of the situation, and give a warning to the driver so they can take steps to avoid the accident, or even to the extent if the driver doesn't react in time, to automatically apply the brakes and avoid an accident. Then likewise, you can also be talking to the traffic lights around you. So not only do you know that the traffic light ahead is red, but you can also receive a message from that traffic light telling you that it's going to turn green in 20 seconds, for example. So you can continue to drive at the speed limit and you end up stopped at the traffic light, or you can slow down to reduce your speed, and by the time you reach the traffic light, it would have turned green and you can sail through. And that can really start to improve things like congestion, getting rid of stop-start traffic, and also have environmental outcomes, because obviously if you're driving more smoothly, then you're not using as much fuel and so on. And it's this connected vehicle technology that can really start to exploit the network effect on our transportation systems to really try to improve safety, mobility and the environment. So they're the big three targets of this new technology. And so in terms of safety, what can we do? So our vehicles will be able to talk to all the vehicles around them. We can share sensor data between the vehicles, and perhaps more interestingly, share intention data. I'm about to turn right, or I want to change lanes, I want to merge, things like that. We can also be aware of vulnerable road users, because a vast number of pedestrians and cyclists today are carrying devices, and we'll be able to sense them as well, and be really aware of these more vulnerable road users and take steps to avoid accidents with them. And really, in essence, it can make us extend our perception, our horizon of perception, so we can be aware of issues that we really can't even see. And it's estimated that this sort of technology can play a part in something like 80% of all accident scenarios. So it really can have quite a dramatic impact on the number of accidents and fatalities on the road. Likewise, in the mobility sense, so connected vehicles can be now tightly integrated with our roads so that we can enable a more finely tuned traffic management, really having the whole system working as a smoothly running machine. And it's estimated that such technology can cut travel delays by a third and increase or decrease freight delivery times by around 20%. So really, quite big outcomes in terms of reducing congestion without having to have the expensive infrastructure of new roads and so on. And that also has a flow-on effect into the environment. So by keeping these vehicles flowing, we can really reduce fuel consumption, or when we move to electric vehicles, also the converse of being able to extend electric vehicle ranges. And that in turn, of course, will lower CO2 emissions. And it allows us to generate some data to allow people to make better eco choices. Like the traffic is very heavy right now, very congested, so perhaps it's better to take the train or the bus or some other alternate means of transport. And so this is really starting to become a big push around the globe to move toward the technology. And already we're starting to see some deployments, big trials happening around the globe, which Coda is a big part of, as well as deployments into production vehicles. So today, Coda is applying into GM and VW vehicles, this sort of technology. But a big part of the conversation around transportation today is also focused on autonomous vehicles. But I think it's true to say that, I think the connectivity is essential for these autonomous vehicles as well. Today, a lot of the focus is just really in an autonomous vehicle is trying to replicate a human driver. And that's, as researchers are finding, that's a very difficult problem. Because, and that's why we see these prototype vehicles out there which are, bristling with sensors, with a supercomputer at the core, essentially trying to mimic a human driver's, eyes and brain. And that's really kind of tough and quite challenging. However, if instead we really start to leverage the network effect and really allow these vehicles to talk to each other, we can do a lot more. It can be a lot more effective system. The way I think about it is trying to build an autonomous vehicle which is completely self-contained, it doesn't talk to the vehicles around it, is a little bit like going back in time and saying, well, boy, all these computers are great, but what would the value be in connecting them together into some sort of network? Well, that's the network effect, and we know what that value is. And so I think the same applies to these vehicles, getting them out on the road, getting them talking to each other and really seeing more. And that's really reflected now in the policies that are coming out globally. So in the US Department of Transport, they see this convergence of the connected vehicle and the autonomous vehicle into what's being called the connected automated vehicle, or CAV. So that's a big part of the terminology today. It's not just automated vehicles, it's connected automated vehicles. Likewise, in Europe, the European Commission's quite visionary Declaration of Amsterdam, they see this convergence of the digitisation of our traffic and the automation of the vehicles. And so over time, what we're going to see, vehicles are going from connected to cooperative to fully automated. So we really get the maximum benefit from all of this. And that's certainly an area that CODA is active in the moment, is research into these connected autonomous vehicles. We, obviously the company, because we're a connected vehicle company, we really focus on the C part of the CAV. How can connectivity improve the performance and lower the cost of an automated vehicle? And we've got a short video here to give you one example of the sort of work we're doing here. So one area of research we're doing is what's called cooperative perception. It's really allowing vehicles to share their sensor data, and so they can really extend their horizon of perception and get much better outcomes than a standalone vehicle will have. So there's just this short video hopefully giving you an idea of what that can consist of.
For the safe and effective operation of vehicles in our cities, the perception systems available must be of a high quality. One way to help autonomous or manual driving is through the use of CODA wireless collective perception messages, where ITS devices, such as connected vehicles and roadside units, share what they know about the world around them. Any information available at the intersection where roadside units are placed is shared down all streets, enabling receivers, such as vehicles, to see around corners with sensors they don't have. They do this in real time and with high fidelity, at least for their immediate surroundings. It is the non-line of sight conditions that make the perception problem even more difficult. Devices can't react to things they can't see. Radars, LiDARs and cameras are all based on line of sight, just like humans. Because non-line of sight creates perception gaps, it is best to enable sharing by multiple distributed ITS devices to fill in these gaps. Standards are being created now to enable this sensor sharing across suppliers. By sharing perception data, each receiver now has information available from multiple outposts, enabling safer and more efficient decisions. Let's take a look at some examples highlighting the valuable importance of CODA wireless collective perception solution. Whether the perception sharing is happening from roadside units or other vehicles, the invisible can become visible. Here we see a cyclist behind a bus, thanks to the roadside unit in the intersection ahead of us, or perhaps the bus's onboard sensors. And now we are approaching an intersection with a green light, letting us know it is safe to travel through. But, thanks to sharing by either the vehicle waiting to our left or the roadside unit, we are alerted to a van about to run a red light directly in front of us. Using the shared data from a car ahead of us as an outpost allows our vehicle to perceive pedestrians that may be about to make an error of judgment. Our vehicle can safely take action even though conventional line-of-sight sensors are blind to the threat. Through sensor sharing, collective perception enables real-time digitisation of our entire surroundings, even when hidden, making the unknown known and making the known accurate. For more information on CODA wireless collective perception, please contact us via codawireless.com.
Yeah, so I think that hopefully that gives you a feel for sort of these future, I guess, computer networks that really are operating on our road network. So high performance compute platforms coupled with communications between the vehicles. So I guess just in closing, sort of the takeaways that I'd like to leave you with. Obviously, computer networks have benefited hugely from the network effect, but likewise, our connected vehicles will also benefit the same, so that the connected vehicles of the future will be safer, spend less time in traffic, and have a reduced impact on the environment. But also another key takeaway is, of course, that autonomous vehicles need to be connected as well. In order to realise the maximum benefit that autonomous vehicles can offer, we need that connectivity as well. So thank you.